Hey, welcome back. Happy 2021, everyone. So in this video, I'm going to go over chapter 4.6. We're going to be looking at similarity transformations. So a similarity transformation is a type of transformation to a figure that preserves its shape but changes its size. So make a note here. Preserves the overall shape, but changes the size. Okay, and so you'll notice that all of these problems involve a dilation, right? So here's a dilation in question number 1. Scale factor is 3, so it's being enlarged 3 times as big. Question 2 involves a dilation. The scale factor is 1/4, so that's a reduction in size. Question 3 has a dilation. Scale factor is 2/3. Again, that's less than 1, so it's going to be a reduction in size. Okay. So the thing about similarity transformations is that they always involve a dilation. All right. So let's look at question number 1. Okay, so we have 4 points. That's going to form a quadrilateral. So let's go ahead and plot these. 3, 6, 2, 5, 4, 3, and 5, 5. And then we're going to translate it, okay, by subtracting 5 from each x coordinate and subtracting 3 from each y coordinate. So let's just record it here. Okay, so I'm going to subtract 5 from each x coordinate. So 3 minus 5 is -2, 2 minus 5 is -3, 4 minus 5 is -1, 5 minus 5 is 0. And then we're going to subtract 3 from each y coordinate. Okay, 6 minus 3, 5 minus 3, 3 minus 3, and 5 minus 3. Right, so that gives us a new set of points or coordinates, and we're going to plot these. -2, 3, -3, 2, -1, 0, and 0, 2. And then lastly, we're going to do a dilation. We're going to multiply each x coordinate by 3 and multiply each y coordinate by 3. So basically everything's going to get multiplied by 3. So -2 times 3, 3 times 3, -3 times 3, 2 times 3, -1 times 3, 0 times 3, 0 times 3, and 2 times 3. All right, so after multiplying each x and y coordinate by 3, we have a new set of points, and then we're going to graph this. This is going to be the final figure. Okay. -6, 9, -9, 6, -3, 0, and then 0, 6. Right. So basically, we're just kind of adding and subtracting to the coordinates when we do a translation, and we're multiplying when we do a dilation. All right, let's look at question number 2. All right, so this looks like it's going to be a triangle because we only have 3 points. Okay, so we have 12, 8, 8, 0, and then 0, 4. And then the first thing we're going to do is we're going to multiply each x coordinate by 1/4, or just divide by 4, and then do the same thing to the y coordinates. Okay, multiply by 1/4 or divide by 4. Okay, so 12 divided by 4 is 3, 8 divided by 4 is 2, 8 divided by 4 is 2, 0 divided by 4 is 0, 0 divided by 4 is 0, and 4 divided by 4 is 1. Okay. So if we graph this, what we're going to see is a much smaller triangle. Should be 1/4 the size of the original. So 3, 2, 2, 0, and 0, 1. The last thing we're going to do is reflect in the y-axis. Okay, so that means we're going to flip it across the y-axis. Okay. So all that's going to happen is that the y-coordinates are actually going to stay the same, and the x-coordinates are going to change their sign. So let's just change the signs of all the x-coordinates, -3, -2, 0, and then we'll keep the y-coordinates the same, 2, 0, and 1. Okay, so now we'll have -3, 2, -2, 0, and 0, 1. Okay, so we've literally just kind of flipped the blue triangle from the right side over to the left side. Right. Our last similarity transformation involves a rotation combined with a dilation. Okay. All right, so let's graph the original figure first. Again, it's a triangle. We have 3 points, 9, 6, 3, 3, and -3, 6. And then we're going to rotate it 90 degrees about the origin. Well, here is some tracing paper. I like to use it when I do rotations. So here's the original triangle. Let's also trace the x-axis and the y-axis. Okay. So remember, when we rotate, the default direction is counterclockwise. Okay. So I'm going to rotate it 90 degrees as a quarter turn. Okay, and just wait till the axes line up again. Boom, there it is. Okay, so our new triangle is going to have vertices here, here, and there. Okay. Let me just so there's one. There's one. Here. There's one. Okay, got it. Okay, so let's record the coordinates. Okay, so this point got rotated over here, so it's now -6, +9. Okay, this point got rotated here, so it's -3, +3. And then this point got rotated down here. It's at -6 and -3. All right. And then at this point, we're going to do the dilation. We're going to multiply the x-coordinates by 2/3, multiply the y-coordinates by 2/3. All right, so -6 times 2/3. Boy, what's that going to be? -4. 9 times 2/3 is going to be 6. -3 times 2/3 will be -2. 3 times 2/3 is +2. -6 times 2/3, -4. And -3 times 2/3, -2. All right, hopefully I did all that correctly. All right, so let's go ahead and plot these new points. -4, 6, -2, 2, and -4, -2. Okay. So we're seeing a slight reduction there between the blue triangle and now the final one, which is the red triangle. Okay. But what you'll notice is that the shape has been preserved, right? It's the two triangles have the same overall shape, right? These triangles have the same overall shape, right? And these have the same overall shape. The only thing that's changed is the size, right? Here we enlarged, so we have a much larger shape, much larger quadrilateral, but same overall shape. Here we reduced it, so it's a much smaller triangle. And then here we did another reduction, so it's a slightly smaller triangle.